Chapter 4.3, Riemann sums and definite integrals. Day 2, properties of definite integrals. First off, welcome back from Christmas. Just review, a definite integral, the integration of f of x with respect to x from a to b, that is the area under the curve f of x from a to b. We're going to look at some properties of this today. First two properties, sorry. If f is defined at x equals a, and we find the area from a to a, we're looking at basically a rectangle with zero width. 0 times anything is 0. If f is integral on a to b, and we switch the order from a to b, what happens is we make it negative. So if this is one value from a to b, when we switch it up, it's like going backwards. In math, whenever you go backwards, you make it negative. Those should be two pretty commonsensical ones. And if we have an integral from a to b, you got our function from a to b, and we got some arbitrary c in there, say it's right there, we can go from a to c, and then from c to b, and it'll be the same as doing the whole thing. And that's no matter where we put c, because if we put c out here, to go from c to b, we're going backwards, so it'll be negative. So if we got a, b, and c, the integration from a to b is the same as from a to c, and then from c to b, even if c is not between, because of the going backwards thing being negative in math. All right, let's look at a few examples. Oh no, let's look at one more property. Sorry about that. Like taking derivatives, if you have a constant out on the derivative, you can take the derivative of the function and multiply it by the constant. Well, same thing with antiderivatives or integration. If you have a constant there, you can find the value of the integral and just multiply by the constant. All right? And then adding or subtracting integrals, you can split those up into different integrations. Just like with differentiating, you can split addition. Integration, you can split addition. All right, now I think let's look at some examples. All right, so what is the area under f of x from 0 to 2? Okay, here's 0. There's 2. We want the area underneath the curve, but since the curve is underneath the x-axis, it'll be negative. It's a quarter of a circle, so it will be pi r squared over 4. And then r is 2, so it'll be pi times 2 squared over 4. 2 squared is 4. 4 over 4, this would be pi. So from 0 to 2 is pi. Right? What is the integration from 2 to 6? If we take a look at it, it's a rectangle, a triangle from 2 to 6. The height is 2. The base is 4. Area of a triangle is 1/2 base times height. Half of the base is 1. 1 times 4 is 4. From -4 to 2. Okay, now we did part of this already. We found out that this was pi. I've got to go back a couple slides. I just realized I made a mistake. This is under the curve, so it should be negative pi. We'll fix that. Negative pi. All right. Now back to this, now that we've realized my mistake from ahead, most of you probably got that already. That's negative pi. This then would also be negative pi, so from here to here would be negative 2 pi. This is a triangle. Half base times height. The height is negative 1. The base is 2. That would work out to negative 1. So negative 1 minus pi, negative 1 minus 2 pi. All right, so we got all of those. We got all those shapes now. Negative 1, negative 2 pi, and 4. Negative 1, negative 2 pi, and 4. As we look at this question, what is the area under the curve from negative 4 to 6? Well, we've pretty much done this before. We just need to take our old answers and combine them. So we got 3 minus 2 pi. Negative 1, 4, negative 2 pi. What is the area under the curve from negative 4 to 6 when we do the absolute value first? Well, that's not too difficult. Absolute value says make it positive. So what is the area when we make it positive before we calculate it? I'll make them positive and add them up. 5 plus 2 pi. All right. What is the area here under the curve from negative 4 to 6? But let's add 2. Now the best way to do this is to split it. From negative 4 to 6 of f of x dx plus from negative 4 to 6 of 2 dx. Now if we go back a couple slides, I think it's 2 slides, we can see that from negative 4 to 6 is 3 minus 2 pi. So we got this part right here. 3 minus 2 pi plus, now what this is, it's the area under 2 from negative 4 to 6. So let's draw this new function here. Area under 2, we'll pretend that goes through 2. And so we're looking for the area under 2 from negative 4 to 6. We can see we got a rectangle 2 high, 10 wide. 2 by 10 is 20. So that area overall ends up being 23 minus 2 pi. And all we did is we split it. We took our answer from the old and we added on our new portion. All right? Let's use that philosophy or that property here. Evaluate the antiderivative of negative x squared plus 4x minus 3 with respect to x from 1 to 3. And they gave us the individual pieces, x squared, x, and 3. All right, so what we want to do is we want to split it. We got constants there, so we're going to pull those out. And what we get is negative from 1 to 3, x squared dx, plus 4, antiderivative from 1 to 3 of x dx, minus 3 times the antiderivative from 1 to 3 with respect to x. All right, now we know these pieces here. So we'll replace those. This becomes negative 26 thirds plus 4 times 4 minus 3 times 2. So there we go. And if you want to simplify that, which is not at all necessary for the AP exam, you can do so. Negative 26 thirds plus 16 minus 6, 5 thirds, 4 thirds. Alright, so in review, there are 4 properties we talked about today. The first property says that if you switch the letters, you're going to have the same area, just negative. That's because you're going backwards when you take the area. Okay? From A to B, the area under a function from A to B, you can split that into 2 pieces, from A to C, plus from C to B, no matter where C is. C can be between A and B or not, and that'll still be true. If there is a constant in front of f of x, you can pull it out and just find the antiderivative of f of x from A to B and multiply by the constant. Or you can add your functions. Do it all at once is the same as splitting it and doing it in separate ones. There's one more I forgot to put here. The antiderivative from A to A of f of x with respect to x is 0, because basically you're looking at a rectangle with no width.